welcome back. So what we're looking at today is 4.4, Reflections of a Bike Lover. So let's go ahead and jump right in. So what we're looking at here is reflecting images. So we want to reflect triangle ABC across the line y equals x, which is shown. Label the new image as triangle A prime, B prime, C prime. Label the coordinates of points A prime, B prime, C prime. Connect segments A prime, B prime, C prime. Describe how these segments are related to each other and the line y equals x. So the main thing we're going to focus on is the reflection across this line here. So when we're reflecting across the line y equals x, we have this rule. X, y, we take the original points and then we switch them. So the point A, -4, -2, is going to become -2, -1, 2, 3, 4. So that is our A prime. I'm going to make this bigger. So this is our A prime. Now, B prime is -6, 3. So we're going to go 3, 1, 2, 3, and then -6. 1, 2, 3, 4, 5, 6. So there's our B prime. And then C, it's -3, 5. So we're going to go all the way over to 5. 1, 2, 3, 4, 5. And then down 3. So this is our figure. So this is our C prime, and this was B prime. I'm going to attempt to draw the lines to connect these. Obviously, they probably aren't going to be the straightest, but you'll get an idea. You guys will be able to do a lot better. But there is our triangle. Now, obviously, mine does not have as straight as sides as the original, but this is the reflection. So if we folded down this line, these two would perfectly line up. The relationship between A and A prime, B and B prime, this is what it's looking at having us do. And C prime. Now, obviously, my lines are not the straightest. These segments are parallel to each other, and they're perpendicular to the line of reflection. So parallel to each other, perpendicular to y equals x, which is the line of reflection, which is key. When we do these, they should be perpendicular. All right, the next one we're going to take a look at is number 3. So a table of values for a four-sided figure is given in the first two columns. Reflect the image across the line y equals x. Write the coordinates of the reflected image in the space provided. Remember, the relationship is just switch your x and y. So for A prime, it's going to be 2, -6. For B prime, it's going to be 5, -4. For C prime, it's going to be 3, -2. And for D prime, it's going to be -1, -3. So reflecting over the line y equals x is all about just flipping your x and y values. All right, our next section, absolute and nonlinear functions. So figure 1 is the graph of a sound wave. The height or depth of the graph indicates the magnitude and direction f of x reaches from the norm or the undisturbed value. In this case, that would be the x-axis. When we are only concerned with the distance from the x-axis, we refer to this distance as the amplitude. Since distance alone is always positive, amplitude can be described as the absolute value of f of x. Use the graph of a sound wave to sketch the graph of the absolute value of the amplitude, or y equals f of x. So that means everywhere that we have all these downward points here are going to be up now. So everything is going to be up above the let's see what they call it, the undisturbed value, or the x-axis. So rough sketch of this, but it's going to come down and then right back up and down and right back up and down and right back up and down and right back up and so on and so forth. So it's always going to be, and they should touch the x-axis. I just couldn't see that I wasn't reaching it. But it should look like this, because every place these are negative, we have to then flip them and bring them up here. So there'd be a peak here, there'd be a peak here, there'd be a peak here, and here. So we're going to have peaks everywhere that originally we had the dip downs, because now everything's going to be positive. All right, number 7, write the piecewise equation for h of x equals the absolute value of g of x as defined in question 6. So question 6, well, question 5 technically, we have this equation right here. What you guys will be doing, so you got the table of values. What would the table of values need to change in order to have it be the absolute value? So looking at these, you'll answer that question. For 6, you're going to graph what this will look like. So when we do this, we have to change a portion. So when we graph and write equations for absolute value equations, we have to change something. So the first part, the positive side, is going to stay exactly the same because this was already going in a positive direction without negatives. So this is from negative 8 is less than or equal to x is less than or equal, is less than 6, and 0 is less than x is less than 6. So this has 2 different parts, and once you graph it in number 6, it's going to make a lot more sense. So this will actually help you immensely when it comes to graphing this, okay? So will the table of values. Just remember what you have to change in order for this to be true. Now, for the missing part, so from, that should say negative. From negative 6 to 0, we're going to use the other function. So negative 6 is less than or equal to x is less than or equal to 0. Now, the other function is just the inverse of the function. So it's the part that would be going down. So we have to be careful when we do these in representing what this actually looks like. So be very careful with these. All right, the last part, simplifying radical expressions. Simplify. Write the answers in simplest radical form. Some answers may consist of numbers with no radical signs. That is completely possible. All right, for number 9, we have negative 10 minus root 13 minus negative 11 plus 5 root 13. So remember, we can combine these two. So negative 10 minus negative 11. So really negative 10 plus 11, which is going to give us a positive 1. And then we look at these two. Negative 13, negative root 13 minus positive 5 root 13. So negative 1 minus 5 is going to give us minus 6 root 13. There's our answer. All right, the next one we're looking at is number 13. So 13 throws in some variables in there. So we have 3r squared minus 8 times the square root of 3b squared minus 2r squared minus 3 times the square root of 27b squared. So in order to take and do these, we can do the first part for sure. They match up. So 3r squared minus 2r squared is going to give us 1r squared. But now this part here, we have 3b squared and we have 27b squared. That doesn't work out. So we have to take and simplify the 27b squared. So if you think about it, 27b squared, we're going to leave the b squared because the b squared is also in this one, so we're not going to change that. But the 27, what's a perfect square that goes into 27? Well, 9 times 3 is 27. 9 is a perfect square. The square root of 9 is 3. So we're going to have 3 square root of 3b squared. 3b squared, 3b squared. They match up now. Now we take this 3 and multiply it to this 3. So really, this is the same thing as 9 times the square root of 3b squared. So we have 8 minus negative 9, which is going to give us 8 plus 9, which will give us 1, or negative 8 plus 9, which will give us 1. So we're going to have plus 1 root 3b squared. And there's your answer. All right, and this last one here, write an equivalent form using exponents. We have the square root of x, we have the square root of x cubed, the square root of x to the 5th, the square root of x to the 7th, the square root of x to the 9th, x to the 13th, so on and so forth. So remember what we know about taking the square root of values. That will help you, and what it looks like to convert to radical form. I'm going to give you a hint. On the outside, you're going to have x to the 1/2 times 1 plus x to the 3rd plus, you can fill in the rest. Hopefully you'll see what this pattern is, what this looks like, dealing with these radicals and the rational exponents. So your keyword for this lesson is radical. If you guys have any questions, feel free to ask. Have a great day. Bye, guys.